Okay, everybody, we got hydrocarbons. It's good to see everybody. I know it's been a while. This should put a bow on the homework from last week in case you were wondering about how to do some of these drawings. Now, these are some of the drawings, but not all of the drawings. But it's a pretty representative sample. If you can do these, you can probably do just about anything that's not here. Okay? So I have them numbered up here. 21A is the first one. Now, these two are both abiding by this formula, so they're both alkanes. So that means 2N plus 2 hydrogens for every N carbon. That means all single bonds, all saturated. So fill them in. I have the backbone up here of all of these, and then I'm just going to fill in the bonds. Okay? So here come the bonds. Now hydrogens are so plentiful that we don't really write them, okay, unless we absolutely have to. Okay? And this one I already did. You can see I got lots of bonds here. The hydrogens are there. You just don't have to write them. It just kind of saves you a step. Okay? So there's 21A and 21C. Again, both alkanes. I don't have room to do them all. 25B. Now this one's C6H12. Now this one doesn't have 2N plus 2 hydrogens. It has exactly 2N, twice as many hydrogens. So that means somewhere in here there's a double bond. Now it doesn't really say where it is. So you can put it anywhere you want to. I'm going to put it down here at the end. Okay, there's my double bond. Now remember, when you're filling in the rest of this, every carbon, 4 bonds, no more, no less. Okay, so this one's already got 2, so give it 2 more, space them out a little bit. This one's got 2, 3, 4, and then the rest is all single bonds, just like we were doing before. It's a little tight here. Okay, so there you go. That's hexene. Okay. These are anes. This is an ene. Okay? Over to the extension, the last page. Now here you have the carbon backbones. I haven't put in any extra bonds yet, so let's see what we have here. All right, now C4H6. This has 2N minus 2 hydrogens. Okay? So that means somewhere in here there's a triple bond. Now it doesn't specify where that is. Okay? So again, I'm going to put it down here at the end. Okay? And that means this carbon already has 3 bonds, so it's only got room for 1 more. Okay, this carbon is all bound up. Okay, 1, 2, 3, 4 bonds. Okay, so that's why there's fewer hydrogens, because there's more bonds between carbons. Okay, and then if you get to the right here, pretty much straightforward. Now I could have put the multiple bond anywhere, and that's where the numbering system comes in. Speaking of which, here's heptine, and specifically it's 2-heptine. So it's a triple bond starting at the second carbon. So 1, 2. I'm counting from the left. You could count from the right. But I'm going to count from the left. Carbon 1, carbon 2, triple bond. Okay? And then as we fill in the rest of the bonds, pretty straightforward. Every carbon, 4 bonds, no more, no less. So this one on the end, no problem. This one's got 4. This one's got 4. All right? And then as we get down here, pretty straightforward with single bonds. And if you were to count everything up with the heptine, double check me, but this should be C7H12, 2N minus 2 hydrogens. Okay. Finally, 3-hexene. This is extension E. These should give you a guide to the rest of the ones I didn't do. Okay. What's the 3 mean? That means the double bond. This is an ene, so it's a double bond starting at the 3rd carbon. So right here, there's the first bond, and there's the double bond. All right, so 3-hexene. You can actually flip it around, wouldn't make any difference. Okay. Again, fill in the bonds. 1, 2, 3, 4. 1, 2, 3, 4. This carbon has 3, so just give it 1 more. This carbon has 3, so give it 1 more. And then it's pretty much straightforward after that. Okay? So that's some of your drawing for hydrocarbons, which should pretty much wrap up last week's homework. Okay? We're going to add some complexity to this with elements other than hydrogen and carbon in the next video. And just keep in mind, we're making 2-dimensional drawings of 3-dimensional structures. So when we get out the models in a few days, maybe next week, they're going to look a little different, because in reality they're really 3-dimensional. Okay? So try to wrap that up, and hope to see you soon, and always stay safe. Thanks.